Hello, in this video we're going to continue on with Chapter 8 in our Introduction to Hypothesis Testing. We're going to continue on understanding the logic of hypothesis testing, and we're going to conduct a two-tailed z-test to make a decision. So if you remember, in the last video we went over the first two steps in hypothesis testing, which was to state the hypothesis, our null and alternative hypothesis. And then we also set the criteria for the decision, which was our alpha level or our significance level. In this video, we're going to collect data and compute our sample statistic, and then we're going to make a decision. And again, just to remind you, here was our example that we had in the previous video. So the first thing we're going to do is compute our sample statistic, or our z-score, to show the exact position of the sample. So that's the position of the sample in relationship to that critical z, or that boundary that cuts off that critical region. So if we look here at our data, we're going to pull out, I've highlighted some of the important information. So one individual was randomly selected. So that means that we have an n of 1. So we had an n of 1. We had a mean of 30 with a standard deviation of 4 and a significance, or an alpha level, 5% was our significance level, 0.05. And our score from our new sample, so we'll say that that's the mean, was 40. So here it is all laid out here on the slide. Some important things to remember. The data is always collected after the hypothesis is stated. Data is always collected after establishing the criteria, or your alpha level. And this sequence makes sure that we are objective in our analysis. So z equals the mean, which is 40, minus, this is our sample mean, minus the population mean, which is 30, over, all we have is our standard deviation. So we need to calculate the standard error. So remember, we're talking about a sample mean here, even though our sample is only 1. And we did this for the purpose of making things easy. So it would be over the square root of 1, and obviously that's just going to be 4. So this equals 10 over 4, which equals 2.5. So now we need to make a decision. And if our sample statistic is located in the critical region, the null hypothesis is going to be rejected. So remember, this was our critical boundary, so our critical z-score being 1.96 on each side, because we have two tails. Remember, we said that there was 2.5% in each tail, which gave us a probability of 0.025. And if we looked up this number in the unit normal table, we came up with a z-score of 1.96. Again, that's our critical z-score. So if the sample statistic is out here in this region, we reject the null hypothesis. If it's not, if it's in this region, we fail to reject the null hypothesis. So if it's in the critical region, the null hypothesis is rejected, and if not, we fail to reject it. So remember from the previous slide, our calculated z-score, that calculation that we did, was 2.5. So it's a positive number, so it's going to be on this side. Now the question is, does it fall in its critical region? This is 1.96. Does 2.5 fall out here? It does. It's not because it's 2.5%. It's because the number is 2.5. So we had our critical z from the table. Our z is calculated z is 2.5. Our critical z is 1.96, so we reject the null hypothesis. Our score falls out here somewhere. So we reject the null hypothesis. So a result is statistically significant if it is very unlikely to occur when the null hypothesis is true. So that means the conclusion is to reject the null hypothesis. So remember, if our null hypothesis is that the mean is 30, our result is statistically significant if it falls in this critical region where it's very unlikely that that score would occur if the null hypothesis was true. And the way that we would write this in the literature is something like this. The training program has a significant effect on friendliness scores with a z of 2.5, comma, and then you put your alpha level. And because we're calculating it out, we don't have a specific alpha level, we just know that it's less than 0.05. So you'd write z equals 2.5, that was our calculated score, and that it's significant, excuse me, at a p of less than 0.05. And this is important. You want to know what this would look like going forward. So just for two-tailed test, it's again kind of like that, the rule that we had from the previous chapter where we knew what percentage fell within certain z-score boundaries. We know that for an alpha of 0.05, our critical z is going to be 1.96 plus or minus. We know that for an alpha of 0.01, it's going to be 2.58 plus or minus. And for an alpha of 0.001, it's going to be 3.3 plus or minus. So this is, again, remember, this is only for a two-tailed test. This is when you're talking about having one tail and two tails. So this keeps you from having to look up your z-score for every single calculation. If you know these numbers, you don't have to look it up for every single calculation. Now remember, this is only for a two-tailed test. It's going to change when we start talking about a one-tailed test in a different video. So next, please go online and do the Learning Check Kahoot. It is going to be worth 1 point. I prefer your first and last name, but your last initial is okay if you are worried about privacy reasons. But please make sure you do that so I can give you credit for doing the Kahoot. And then you're going to go on and you're going to do the student-led example. So that should be, hopefully you followed along on the handout and you did the teacher-led example, and now go ahead and do the student-led example and then watch the video afterwards to check your answer.